What exactly do we do? I'll explain a little bit more about the security threat landscape that we are addressing, right? And then we'll talk about how do we want to protect the modern applications, what are the best practices, and I'll also show you guys our enterprise product in terms of how it will look and work as well around some of these principles. But it's also I'll also share with you guys some of our open source tools that you can try out to get your hands dirty as well. So first of all, for Aqua, right, where do we play? We are focused on securing modern applications. We're focused on securing cloud native applications. So, first question, can anybody explain to me what do we mean by cloud native? Yes. So very good answer. So the you have the right gist of it, right? The gist is that you are building and running applications that run natively on cloud. Okay. Another any other take from anywhere in the crowd? Any other way to look at it? Okay. So yes, as I was talking about, right, with cloud native, we look at workloads like native services like Microsoft SQL. We look at containers that are supposed to run on any infrastructure in cloud. So it could be like AES service in Azure. It could be ACI, which is the running system of containers. It could be serverless functions. Right? So you're building and running applications that are very easy to deploy, right? So Aqua, what we do is we help to secure and manage this for customers, and we do end to end. So we do shift left, right? So other question, what do you understand by shift left when we talk about applications and security? What does shift left really mean? Okay, and you were saying something else? Okay. Yeah, something like that. So both are have the right approach, right? So okay, since you guys spoke first, you get the last two umbrellas. Okay. So shift left is you have your developers who want to start writing code, right? And then the code will be inside like GitHub or Azure code repositories, right? And then you will have CI/CD pipelines which are meant to automate a lot of processes. So from code you get ready to the artifacts for your application. Then you deploy as applications, which can be running as a VM, as a container, as a serverless function. Right? So shift left is a lot about whatever changes you want to make to the application, you do it on the left side. That means security also has to move left. Right? This is where we integrate with like your Azure DevOps, your ACR, which is hosting your images for containers, your Azure pipelines, and we have to secure that. Okay? Then there's still shift right because your application is going to run in a live production environment, right? And that's going to serve your customers. So that is still your most important asset in terms of technology, right? Your application data. So then we still need to think about how do we want to protect these applications running in, let's say, APS service or ACI or Azure functions, right? In the context of Azure. So we will discuss how we can do that. Now, Aqua as a company, we are based worldwide. Singapore is our one of our main regions in APAC. We have been partners with Azure for a very long time. So Azure was actually one of the early investors in Aqua, and we were a younger startup. Now we are much bigger, I would say, right? And we are also available on Azure Marketplace. So when customers, let's say they want to procure Aqua to protect their Azure environments, they can do it directly with their Azure services, right? And then we also see Microsoft as a customer. So what I have liberty to say here is that we are intensely working with them from our open source perspective. So Azure Defender is Azure native security service, right? And it is also using 3D or open source scanner under the hood to scan your images. Similarly, GitHub subsidiary of Microsoft is using 3D integrated into GitHub Actions to scan in your pipelines and secure the pipelines. Okay, but not just Microsoft, we also have a lot of joint customer success stories, right? And these are some of the larger examples of that, which we are working together to, from Azure perspective, to provide the platform to run the applications, build the applications, from Microsoft perspective to then secure them as well. Okay, so let's first try to understand, we talk about these modern applications, what is actually inside the application, right? Typically what happens is that you will have a base image that you will take from open source. That could be Alpine, could be Ubuntu, could be Nginx, could be anything, right? And then inside this base image, you will add your necessary libraries to support your application, right? So if you look at this part, right, this part does not belong to you. This part comes from the internet. So you don't have much idea of the security posture. What, as a company, you own is a little piece that you write and you run to serve the logic or the function that you are providing to your customer, right? So if you think about it, you can personally be aware of security posture of only maybe 5% even 10% of you're actually running in your environment. The large chunk of it, you need to understand the security posture and you need to understand where are the vulnerabilities, where is the risk in my environment. Right? So how does Aqua understand these threats? Aqua has its own threat intel team called Team Nautilus. Right? It's a pretty famous team in the industry. You can easily Google them. There are some examples of the research papers on the top. We will share this slides with you so you can take a look at it later. Right? But what they have done is they have deployed a lot of honeypots in different public cloud environments that puts them misconfigured and vulnerable, and we are observing more than 100,000 attacks a month. So what happens with that is that we get a lot of data in understanding how threat actors are exfiltrating customers' environment, how they're executing the attack, how they're propagating the attack in the environment. And some of the things that we see today is that the attacks are definitely becoming more sophisticated, right? We are seeing 1400% increase in Pulse attacks today. So what that means is that if you're using an agentless approach to secure your workloads in the cloud, you won't see these attacks. So they will go unnoticed altogether, right? There's also a large shift in focus from Docker to Kubernetes because Kubernetes is sort of becoming the operating system of modern applications. It's sort of the way we standardize on any platform, right? In cloud, in on-premises, how you are going to run these modern applications in containers. Okay, so they are shifting their focus on attack vectors on Kubernetes. We also see increase in supply chain attacks, which if we look at it, there's 14% of top 1100 Docker repositories that are being impacted. So when I look at the previous slide and talk about a large chunk of it is coming from open source, and we look at this statistic, we can see that there is a lot of threat coming from supply chain perspective. Okay? They are weaponizing the UI tool for Kubernetes to access backdoors into infrastructure that is running applications. And we see a lot of zero-day exploits on the rise for new unknown threats that can get introduced into a runtime environment where you're actually running the application. Okay? So when I try to put this attacks into a picture from an application lifecycle, right? When we talk about code, the type of threats that we are seeing is, for example, people looking at your exposed code to try to find your secrets, your logic, and then use that to exploit your applications in the runtime. Okay, we see how they are looking for reachable vulnerabilities. So reachable means that okay, there will be vulnerable packages in the environment. You cannot avoid that, right? But which of these vulnerabilities are actually reachable through the code that you're writing, and that makes the vulnerability more exploitable. And so we will discuss that part. And so we are looking at IAC misconfigurations. that you're writing the templates that will then in fact become your infrastructure in runtime serving your applications, right? So you need to identify these steps as well. Now, when we move on to the next point, we need to look at the pipelines that we are using, the specific pipelines that are used to automate a lot of processes to take the code and make it into an artifact that will run your application, right? So within the pipelines, we need to understand, okay, what base image are you using? Is it malicious? Is it vulnerable? And is it safe to use? Right? And even if you have made the base image secure, even if your code you have scanned and everything is found, if you don't know where your pipeline is running in which server, which runner, and if somebody has access in there and they're injecting something malicious, you may have done everything, but just that weak point could result in a vulnerable or attack in your runtime environment. You need to understand those steps as well. Next is when you are deploying the application. So deploying in Kubernetes, you need to make sure the platforms that you're using in Azure, in Kubernetes are hardened, you are visibility into compliance, and you don't allow backdoors for threat actors to enter and introduce attacks in your environment. And lastly, but equally or even very important, is that your applications in runtime are going to face stress. Okay? And as I was talking about in the previous slide, from a research perspective, we see a lot of unknown threats, new threats being introduced. Okay? We see fileless malware being executed in the memory of the workloads. So if you are using, as I said, ELS approach and you are scanning the file systems of the workloads to detect malware, you won't detect this. Okay? So I'll give you an example of one of the research papers that Team Nautilus wrote on headcrab. This is a threat they identified, I think, almost 2 years ago. And since then, the headcrab attackers are still interacting with our threat team to figure out how they detect it, and then they are actually have released better version of the malware to make it even more evasive. Okay, so it's very interesting. You can see the blogs and you can see how they're interacting with us. But what this attack was that Redis is a very popular database. It's open source and a lot of people use it. Okay? Uh, and Redis allows you to load modules into the memory of the database to execute logic to execute current applications. Right? So what this threat actor did was that they managed to load the module which was the malware and run cryptocurrency mining in the memory of the database. So it was completely you could detect it with normal uh, your tools like EDR or your scanning tools using the tools because it's running in the memory of the container. Okay, so just to let you know, for example, they scanned the internet, they found 1,200 instances of Redis being infected, and each instance was giving the attacker 4,500 USD per year. So you can imagine how much money he made for almost a year plus of being unaffected in people's environment. Okay, so now we understand what type of threats are being reduced. We understand how it can impact our environment, right? So let's look at what approaches we need to take to secure cloud-native applications, right? So the first part is shift left, which is where we want to introduce scanning and assurance, right? Scanning is important because we want to get visibility in what is the risk in your environment. That applies to your code, your CSV pipelines, your images and templates, and your actual workloads. Okay? Assurance means adding security gates. So security gates mean that I do not want to allow a developer to merge uh, malicious code or vulnerable code into my main branch. It will result in my artifact becoming vulnerable. Okay. And then similarly, I'll talk about other security gates as well. Then we have the second part is posture and configuration. So from all your DevOps tooling, your source code managers like GitHub, the code repositories, the CSV pipelines to your Kubernetes platform and your Azure environment itself, you need to scan all of that to figure out if there's any misconfigurations or exposure that could lead to access to a threat actor. And to make sure that we are identifying that, we are making sure the environment is compliant and hardened. The last part is runtime protection. This is equally important because even if your image, your workload has been deemed very secure, there could be zero-day threats. There could be new malwares executing in your runtime, and you will detect that with modern techniques and then stop it from happening as well. Okay. Before I continue, any questions so far from anybody? Okay, then I'll ask one question. Who do you think is the leader in runtime protection in the market? All right, that's the way. Marketing, marketing. Marketing is not here, so I must do a job. IDS and IPS generally sit at the network layer, right? So you're detecting, you're scanning the packets. Sometimes you copy and you scan, and then you detect if there's any malicious payload being added into the environment, right? So that is still important. We don't replace that. We don't replace that, right? We are looking at the application itself. So you are as close to application as you can be, and you are protecting it from there itself. But your network should be there, protection should be there, your IES, your WAFs, and you need that to, in the first place, prevent as much bad stuff from entering your environment in the first place. Yeah, correct. Yeah. You have an umbrella, so now you get stocks. Okay, but it's true. We are here in this space. Not just one report, there are multiple reports out in the market that Google as well, and we go. And since then, there has been continuously innovating in this space. And so that's the important part. And it's not through acquisitions, it's through in-house intelligence, in-house expertise and development. Okay, so now I'm gonna show you guys some demos to validate all these parts. Right? So not just talk, but let's walk the talk. So the first part of security is keeping bad out. Okay, so this is where we want to integrate with your code repos, whether it's Azure code repo or your GitHub, for example. You want to integrate with your registries where you're posting your images. You want to integrate with your CI/CD pipelines. Okay, and then we want to scan for malware, secrets, vulnerabilities, IAC misconfigurations, implement supply chain security, integrate with CI/CD pipeline to maintain its integrity, and then also build SBOMs. Anybody knows what is SBOM? Yes, you were being that in my last session. Have I given? Okay, so now you get solved. So, let's see. Okay, before that, software bill of materials, right? Software bill of materials is sort of a mandate now in US by the federal government. It's becoming an industry standard. What it states is that okay, you have built a piece of software. What does your software contain? What are the licenses? What are the vulnerabilities or security posture? So that if you as a customer is taking somebody's software, you should be aware of what is being reduced into your environment. Right? But we also will help you build it. If you take in a third party image, for example, we'll help you build a form as well. Okay, so let's take a quick look at some of the examples here. Okay, so this is Aqua console. This is the Aqua Enterprise platform. And here we have multiple components of the platform. There's supply chain security where I'm at right now. And you can integrate with your GitHub or your Microsoft, and then you can scan the code repositories. Okay, so here I have an example, and we call this scanning universal scanning because it's a single scan that is scanning for SCA. Anybody knows what is SCA? Yeah. So very good. So SCA is identifying what packages, what libraries your software is using, and then what are their vulnerabilities. Right? So we are scanning for that. We will scan your ISC templates for misconfigurations. We will scan for sensitive data, if there's any embedded secrets and passwords that should not be there in your code repository. And we scan for SASC, which is the code analysis to identify if there's any code weaknesses that could become vulnerabilities in your own code, right, which could then be exploited. And then we also scan your pipeline configurations. If there's any misconfigurations, we also highlight that as well. We can go deeper in this, right? Maybe I'll make it bigger first. So we can go deeper in this. One quick question. Yes. You also scan the dependent modules. Example, I have the dependent module. Yes. Right? And then the dependent module has again the dependencies. Correct, correct. Do you understand? Yes, we'll also scan that. We'll also provide you with modules that must integrate with us in the CI/CD pipelines, right? There'll also be transitive packages, right? We'll also identify those and list those once you integrate us with the pipeline and you're building the SBOM. You'll also get those packages as well. Yeah. Okay. I'm just going to quickly show one or two things here. So from vulnerability perspective, you can see the list here. You can see which of these vulnerabilities are reachable by code. This is about prioritizing what you find. So at first perspective, it's not just identifying vulnerabilities. How do you operationalize the results? Yes. Very good question, right? Yes. Let me repeat the question for our online folks. So the question is that where do we prioritize the aqua findings, right? And I'll add another part there, which is how do you do it, right? So firstly, you have socks. Okay. If you don't like socks, then you can come to me later. We can change. Okay. So the the question is simple, but the answer is not, right? The thing is, you want to integrate with two aspects. One is from the security aspect. Security team needs to know where are the risks being introduced, and that's what I'm showing you here, right? From a developer's perspective, you want to inform them as early as possible because you don't want to be have done a lot of work and then at the end the security team says, hey, your application has vulnerability. If me as a developer was introduce this information the moment I'm doing a commit, I can quickly make the change and I do not have to do everything and then here I have to start again, right? So the reality is that from a developer's perspective, the earlier you inform them, the better it is, right? So here I have an example, and in this example, this is in GitHub, but you can do the same thing in Azure pull request as well. So can anybody explain what is pull request? Correct. So what you are doing is that okay, you have the main um, main branch, and then as a developer, okay, I need to add more feature, I need to do some changes, I make things locally, and then I merge it with the main branch. So you're pulling the code and you're merging it. So that's pull request, right? Now as a developer, I'm doing that. I'm adding some changes, and here I have Aqua integrated, and Aqua is telling me what I'm finding, and it's telling me also how to fix it, right? So so if you think about it, you are encouraging developers to build secure code as early as possible. And at the same time, you also get visibility from security team perspective that, hey, these are the findings. And then you can also see what has been fixed as well, because all these scan results will also be listed in Aqua console as well. Okay. So this is the first stage. Now, second stage is that, okay, I have a Azure pipeline, and inside there I'm building the image and I'm deploying it, for example. So you can see all the steps that are taking place here, right? And one of the steps you can do is introduce Aqua, and you scan what you're building in there. And it's because here you could be introducing additional libraries, you could be introducing a base image that the developer chose not to use the internal one, but maybe from outside, and then you need to scan that as well. Okay, so you scan that, and then developer will get the findings over here, just like the pull request earlier. What you can do on top of that as a security engineer or architect is that in Aqua you can set policies. The policy is okay, if you detect log4j vulnerability, if you detect embedded password, then fail this pipeline. Because the earlier you fail, the safer you are. If you detect this in runtime, means you are already vulnerable to attacks. So this is the next stage where you want to integrate and inform developers. The moment they are merging code, and then when they are building artifacts from the code. Okay, a great question. So just like the code scanning, right, over here, we'll also scan your images. So we'll integrate with Azure. I have 10 minutes. Okay. So we'll integrate with your image repositories, and then we will scan the images as well, right? So important point here. So we have already scanned the images in the CI/CD pipeline. Why do we need to scan it again? Right? Any answers? Correct. Very good. Okay. I said, okay, this is not an upgrade, but suppose that. Okay. So, yes, you're right. So, just because you have scanned the image in the pipeline doesn't mean that they will not be new vulnerabilities introduced. Also, additionally, you will sometimes add images directly into the registry, or maybe some admin chose to just do a Docker pull and Docker push into your ACR, and then it's there, right? So you need to be able to detect that and scan the images. So let me go here and look at the image. So here I have images. I'm gonna filter to a particular image, okay, which is that. So we have scanned this image, and just like your code scanning, we are identifying the vulnerabilities. Okay, we are identifying, okay, what vulnerability. You click on it, you can see the details, the remediation, and so on. You'll also see all the resources that are inside the image, the packages, their versions, the fix for the versions, their vulnerabilities, and their licenses. Okay, so this is like the SBOM for the image. Okay, and this is also an open source image, right? Now we can do these static scans. Other people know to do. Maybe our scans are results are more better and so on. But what this is not going to detect is if there is a hidden threat in this image. It's not going to detect the behavior of that image, right? So this is where we have sandboxing that we call dynamic threat analysis. And here we are putting that image in a sandbox environment. We are running it and then looking at its behavior. Okay, so from there we're detecting things like communication to cryptocurrency domains, cryptocurrency miners being executed in runtime, and other malicious activities that are happening. This will not be detected by just vulnerabilities. Right? So this is other part of that where how do you stop supply chain attacks? Right? So this is identifying what are hidden behaviors or threats in the images that you're introducing in your environment. Okay, so in this particular scenario, the DBA scan is our own environment. Correct. So, correct. This is a very important point because This is meant for third-party and open source images, because you don't know the incident behavior, right? It's not your code that you're sending to Apple, sending open source image or third-party image to know whether it's a threat. And you don't really want to run this in your environment and then let that behavior execute in environment as well. So yeah, but very good point, right? So the next point is, okay, we have talked about the DBA sandbox scan, is admission control. Okay, what is admission control? Is that okay? We have built, okay, checking the code from developer, and then image is built in the pipeline, right? And now we want to have an enforcement point before it enters our production environment, right? So we want to make sure only secure applications are allowed to run in our ATS cluster or ACI, for example. And this is where the permission control comes in, where you want to block unregistered images or which is because they're not scanned by Aqua, we don't know the security posture. Another one is you only want to allow compliant images. If they're not compliant, they're not allowed to run. So I'll show you a quick demo of that as well, right? Here I have my AKS cluster. So here I have my AKS cluster. I can show you there are a couple of nodes here, right? So this is basically my Azure Kubernetes service. I have 4 nodes which will run my containers. And in my environment here, I have an image. Now, when you look at this image, it's not compliant. This is not compliant because I've set a policy that says you can't have this vulnerability in the image. So we're telling you how to make it compliant, but while it's not compliant, it should not be allowed to run in my environment. So now I come here and I have this deployment file, which is using the same image from my Azure registry, and we are trying to deploy it, right? So I'm going to say, hey, Kubernetes, let's deploy this application. And Aqua will block it because image is not compliant. Okay, so this is the idea of admission control. Okay, I'm not going to let you ask me any questions anymore because we're running out of time. I have a lot of things to show. So you can ask me later on. Okay, so this is admission control. And next part of the solution is drift prevention. Okay, this is a very important feature and it's almost like magic. Okay, the idea is that containers and shift left inherently make applications more secure. The idea is that whatever changes you want to make should be made there. Don't upgrade, don't patch in runtime. You want to make changes there, push out the new image, and then you run it. So they are inherently supposed to be more secure, but the reality is that they can change state, right? So, and change state means that something is happening or executing. Now, this prevention's job is to detect the change of state and then block it. Okay, so if I come here and here I have a container running. Right, so let's say I go into one of these containers. So now I'm inside the container, right? I'm going to simulate a threat. So let's go to the temp folder. And okay, this is from earlier I was testing, but let's say I load malware inside my memory now. So this file wasn't there before, now it is, right? Now I'm going to elevate its privileges. So now I have this executable malware that was not there before, right? So now what we're going to do is we're going to actually try to execute this to actually execute that attack, right? And what happens is that it's being blocked. The reason it's being blocked is because of Aqua. If we come to the Aqua console under workload protection, this is where we are putting in these capabilities. And if you look at the audit report, I will see a block incident happening here. And you can see, okay, the block happened on this container, and this is the location, this is the environment, and who was the user, what was being executed. Right? So you see all the details there. Okay, and what is the control. Okay. Similarly, similarly, we have something which we call CNDR, Cloud Native Detection and Response. What it is supposed to do is look at the behavior of things that are happening inside the workloads, and based on that, detect unknown threats. Okay, I don't have time to show demo, but we can discuss that more later. We have vShield that is supposed to protect your applications against zero-day exploits. Okay, so if there's a new vulnerability, there's no fix for it or it's not being fixed yet. You don't want that vulnerability to be the reason to get exploited because you can't take down your application. It's something you're serving business. So the issue is how to protect against zero-day threats. Okay. Next area is securing your platform. So securing your Azure cloud environment for detecting any misconfigurations across your entire cloud account, and then implementing Kubernetes security posture, okay, to make sure that your platform is compliant. Right? So we actually how to create the CIS benchmarks for Docker and Kubernetes, and then we actually help customers to implement it, right? And lastly, bring all this together into a single place, so then you can see full visibility from code to cloud of the application, right? And if I were to show that to you, it would look something like this. So I showed you earlier the example of scanning the code repository, showed the example of scanning the image, I showed the example of running the container and then detecting what is happening in there. And from a perspective of the security, you should be able to see all of that in a single picture. Right? So you can see, okay, this container has these vulnerabilities, these are things that are executing inside there. And it came from this developer, from this code repository. Okay, so this is about having a full picture of your application security posture. Okay, so from Aqua's perspective, we understand how a threat actor gains access, how they execute the threat, how they persist and escalate, and then impact the environment. Right? Our runtime protection is built around stopping the entire tool chain. Okay, I only showed you one example today, which is drift prevention, which is a very cool feature, right? At least say yes. Okay, that's the way. So yeah, we have built our platform to secure your applications from end-to-end perspective, right? Um, and from Azure perspective, we will integrate with the right platform that Azure offers. From the perspective of DevOps, integrating with your GitHub repositories, Azure DevOps, pipelines, right? Integrating with Azure Kubernetes Service from SIE perspective to secure the infrastructure and the workloads it is running. Integrating from DevOps with the ACI containers, okay? Azure functions, so scanning the functions and making sure they're secure. If they're not compliant, block them from running as well. We can do that. Okay. Cloud security, so scanning the Azure cloud for any misconfigurations. Okay. And lastly, single platform to secure whether it's Windows or Linux containers, whether you're running it in ACI or AKS, we will support that. Right? And runtime security, very crucial, right? And detecting and blocking zero-day attacks in your environment. Right? So that's from Aqua perspective. We are covering a set of use cases that you see in the market today. You might have heard some of these names, right? But they serve the different aspects of the application lifecycle. From Aqua's perspective, we integrate these use cases into a platform. So rather than having three different tools with three different teams with three different results and then trying to figure out what is wrong, you get a single tool that is showing you end to end. And so I'll show you the graph. What is the threat with the application and how to fix it. Okay, that's it for me. I have this slide which basically shows you first approach to securing Azure cloud and their workloads. I also have links to our open source tools here. Privy is the best scanner in the world. Okay, try it out. Tracy is the best open source runtime protection for applications. Free to use also. Try it out. Right. So these are the open source versions of what I showed you today from Aqua Enterprise demo. Okay, and with that, thanks for your time, and hopefully we can chat more later on. Thank you.
Hello, am I audible to you guys? Is that okay if I don't use the mic?
This move that we can
Yeah, I won't be asking any question. You ask me question.
I did but I didn't have time.
Just want to check with the online audience. Are you guys able to hear me? Okay. One of my friend in Norway says yes. Okay. So that means they're able to hear me. Go ahead and share the screen. Okay. All right. Thank you very much, guys. And I would like to thank Arun for having such a wonderful session from Aqua regarding Triviscan and DevOps. So my name is Ritesh. I'm senior staff platform engineering cloud at a media company. I'm MCT from 2020 till 2024. I lead three big communities in Singapore. One is the Azure Community Services, that is this particular which you guys are attending. It's a part of .NET developer community. I'm community lead for HashiCorp user group for Singapore, and I'm organizer for Kubernetes user group Singapore. And I'm certified in all three major clouds. So today I would be talking on a topic getting started with Terraform on Azure. So since infrastructure as service is quite interesting topic, and everybody in the DevOps line, they some other time or somewhere in your life you must have heard that we have to learn Terraform. We need to know Terraform. Each organization, if I know very well, even if they have not implemented it, they are thinking of going into Terraform, or at least they are trying to explore if Terraform is suitable for them. So this is where I would be talking about Terraform, what it is, how it integrates with Azure, what are the providers, what are resource block, Terraform state file. Then we will go into a demo wherein I will showcase how you can run Terraform locally, and local state file, remote state file, and we will also talk about how you can import your existing resources from Azure into Terraform. So let's go ahead. So what is Terraform? It's an orchestration tool for provisioning cloud resources. Okay. It's cloud agnostic, so it is very well capable of running on various different cloud, including on-premises also, like VMware, Tanzu, and I believe even they have got support for Windows AD as well and Windows Server as well. So it uses a state file. What is state file, if you guys will ask me? So state file is a single source of truth when it comes to Terraform. So what else it means is whenever any resource is created using Terraform, a state file is created. That state file holds information about that resources which are managed by Terraform. So it uses state file. If there is no state file, then it will means, let's say you created some resources and you deleted the state file. So Terraform would not understand that, that it was previously created and managed by Terraform. So it will try to destroy and recreate it. So that is one of the important files. Terraform is not a configuration. So what it means is it's a infrastructure as code tool. It helps you deploy, maintain, and continue maintaining and operating your infrastructure as a code, but you cannot use it like Ansible, Chef, or Puppet, wherein you will load your desired state of configuration and you will expect that it has to behave like that. No, it can only behave as a desired state configuration for your infrastructure. Okay. Uh, it uses HashiCorp, HCL, HashiCorp configuration language, which is based on Go, and it has a capability to recover from transient errors as well. Now, when I say transient error, let's say you're running it and it hits some API timeout or some intermittent network issues, it can recover itself when you're running it. So this is where I would like to discuss a bit about it. Thanks to buildfinance.com. So this is a design idea about how Terraform works. So Terraform TF code, you have a Terraform TF code. Now, first you will do a plan. We will talk about this and I will also show you practically how that works and what it does. So if you see, first it will happen the plan. Okay. Now you see from plan, you have a 2 arrow for Terraform state. If you're running the first time, okay, Terraform plan, it looks for TF state file, but if there is no TF state file, it won't create it at this point. Okay. However, when you click up, when you do apply, okay, at the apply, the first time Terraform state file will be created. Okay. And then it will go to the Terraform provider. As I said, provider, Azure RM provider, it is nothing but an API call that it does in the backend, which hits to the API providers on Azure. And Azure Resource Manager REST API, it creates your resources. You want to create storage, IaaS, or something. Now, let's take another resource, another thing wherein I already created infrastructure. Now I want to add one more resource. When I run that, when I do plan, at that time it will refer my state file. It will see that in state file, that particular resource is managed. Okay. It will have the information and it will say, okay, I need to create another one because this was not created by me. Okay. And then again, the same flow will go. We talked about providers. So what providers we have? We have Azure RM providers, Azure AD, DevOps, API, AZ API, Azure Stack. Now the name itself is quite what you say explanatory, but one thing I would like to inform that AZ API. Okay, so AZ API is where if you want to do some kind of beta testing or very new preview, public preview information or those APIs, if you want to explore, utilize, you can use AZ API. But if you want it to be stable, go with Azure RM. Okay. There is a way to migrate from AZ API to Azure RM. So there is a tool which Microsoft has. You can utilize that. See, the management of Azure resources that aren't released. If you see here, management of Azure resources that aren't released. So this is basically for beta testing and If you want to explore, you can do it. Terraform command. So basically, this is where Terraform ends. Means these are 5 commands. If you know very well, you know 30 to 40% of Terraform. Init, validate, plan, apply, destroy. We'll see what it is. Initialize, validate, plan, apply, destroy. Now, when we write a structure of Terraform TF file, these 3 things we have, it's compulsory, or you can say it's important. One is block, Terraform block. You have to define a Terraform block. Within curly brackets is where you define Terraform block. Okay. Now, Terraform block, then you need to have providers. Providers is where you will inform Terraform that you have to use this particular provider. So it will go connect to that particular APIs, and it will make a call to create those resources or change those resources by using the resource block. Hope I'm clear till now. Any questions? Okay. This is what I was talking. So you see Terraform. So these curly brackets. So this is one block. Provider. This is provider block. This is resource block. That's a Terraform block. Okay. So as I said, whatever you give between this, it belongs to one resource or one particular provider or whatever it you have to give it. Okay. It also can interpolate. Okay. So interpolation is one of the important thing of Terraform code. What that means is you can define a variable like var dat of service and plan name, or you can input as a data and you can give the parameter as a data over there. I will show you in the demo. Variables, yeah, this variable is also a Terraform variable is also important. And why is it important is because if you have reusable code, you want to make a reusable code and you have repetitive arguments or parameters that you want to give, but you don't want to write it all the time. So you define it in your variable file and you just specify the variable file, your var file information like variable resource group. You can see the description, or you can create a TF var. You can create command line. Now, these are different ways how you can create variables. The most commonly used is the first one. But let's say if you want to override any parameter within that, then you will go with TF var. Okay. So in the next slide, we will see that for variables, there is an order that happens. And if you give the variables in those order, the precedence takes place. So you can see here Terraform. So all the TF file within your directory, okay, all the TF file, means I'm saying .tf, any .tf file that is in your directory, when you initialize and you plan, Terraform will look for all the TF file irrespective of the name. Okay, it will look for the TF file. It will understand it's a dependency as well. Means you don't need to specify any depends on or some that kind of information. You just specify the resources that you want to create. Terraform will understand what it needs to create, and accordingly, it will do it. So all the TF file has to be there. Now Terraform loads variable in following order. Okay, so the later sources take precedence over earlier. What does that mean is, if let's say I've set environment variables, okay, var variable.tf file, okay, I have set as a var. But let's say for one particular resource, I want to pass some special information. I want to utilize the same variable, but the information, or you can say the value, I want it to be different than what I have specified or which I use commonly. So what I will do, I will use terraform.tf vars and I will specify here. Okay. Then what will happen when I run tf within that directory, even though it is in environment variable, but if it is in tf var, then tf var will take precedence. Then tf var.json, auto.tf var, auto tf vars.json, and at the end, at the command line, if you give this parameter, So the most powerful, or you can say the most precedence which take is at the command line. So all the resources that you create can be output. You can create an output. Output has to be in this block, wherein output, then you give a name, okay, output name, and what value you want. So value is something that when you run TF, it creates resources. After that, from that resource, if you want output, like you want to know the resource group that you have created, the resource group name, if you want to know, then you can output that. Okay. Or you want to know the storage account name, you can output that as well. So Terraform state file. So when you run Terraform, yeah, as I said, it's the source of truth. And so for testing and development, you can keep your Terraform state file locally on your system. But if you are in a big team or in an enterprise, so it's always advisable it should be on a shared storage. So like storage account or your source control, maybe Git, Bitbucket, or whichever source control you have, you can use it. But if you are an enterprise customer, you have a lot of money, go with Terraform Cloud Enterprise version, which manages your what you said, Terraform state. So you don't need to worry about it. Plan and apply. So plan. So the basic difference between plan and apply is in a plan, when you run a plan, it will check what all resources need to be created. As I said, it will check for the Terraform state file. No state file, it understand that, okay, I need to create everything new. But if there is a state file, it will understand, okay, in state file, these all are managed. So I don't need to make any changes to them, but I need to create others. So accordingly, it will give you an output that this will not be changed, only this will be created, is what it will say. But that is only plan. You can out it as an out plan. But when you run apply, okay, that is where the actual configuration will take place. After configuration is means after everything the apply done, your resources are created, the Terraform state file will be updated that these new resources are created and now they are managed by Terraform. Are we clear? Any questions?
You spoke about variables, so it's environment variables, respectively, or it's environment variables plus also application variables.
Can you can you elaborate your question? I think I'm not able to understand what you're looking for.
If I want to run a Python code that is going and reading something,
Okay.
I can set variables in Python.
Yes.
So when you spoke about variables, it's predominantly focused on environment variables only pertaining to my infrastructure.
Uh-huh.
Correct?
Yeah, that is one of the way. Means you can set it as environment variable as well, but it does not restrict you there. You can create as a what you say, a Terraform specific variables as well, and you can parse it over there. So for online for the online attendees, the question was when I spoke about variables, where I said environment variable. So I have means that's where the confusion was. So it's not specifically only environment variable. You can give variable with respect to the Terraform variables, and you can pass those variables as well. So both you can do. So it's not just limited to environment variable. Uh-huh.
Because I know you can only run apply.
Huh?
It will work as well.
Sorry, sorry, I was there. Okay,
Sorry.
yeah, again.
You can only run separation between plan and apply.
Uh-huh.
I know that you can only run apply.
Yeah, yeah, yeah. It was
But-
still.
But the idea is, as I understand it, you can plan on one machine and then transfer the state to the. What's the idea between why the separation between plan and steps?
So plan is just like, you have an option, what if? When you run any PowerShell or Bash command, you have an option where you have fun what if, which gives you information about what will happen if you run this command. So plan does that. What if? That is where you will come to know that what it is doing. Let's say you apply. Okay, and it is it is deleting something. You by mistakenly gave a configuration. In configuration, you have written some override parameter, and it is detecting is like you need to change it. But since that resource cannot be in place change, it has to be destroyed and created. So what you will do when you do apply, it will directly do the apply, right? That is the reason you need to have a plan. It's not compulsory to run plan, but it is always good to run plan. So it will understand, or you can understand better. I will say the better word is you will understand what it is trying to do. And if by any, maybe you have done some mistake knowingly, unknowingly, you can rectify it and you can run it again. Okay. Does that answer?
My question was for you, when you output the plan to the file and then you apply.
Oh, this one.
Yeah, this one. Output and then you apply. And here you like transfer plan, like I don't know, you build like parts of the CI and then you apply it on the machine that has X. Right.
I need to check more about it. I'll get back to you on this. Okay. But I believe, yeah, if you are running it on different machine and then you want to run it, yeah, the you need to have some extra steps to run with it. I am not sure about it. I'll get back to you on that. Okay. So Terraform import, we can use Terraform import to import resources which are existing in your Azure to Terraform so that they can be managed from Terraform. Okay. And need to import one by one each resources. And yeah. Now let's go to demo. Any other questions? Sorry, again, sorry.
I have a Terraform state file.
Okay,
I have few resources,
okay.
and somehow I created few new resources outside of the state.
Uh-huh.
Okay, and now I'm trying to import what I have. Okay, but my current Terraform state file is not what will be pulled. There might be some conflicts.
Yeah.
At that point, how can we do so?
So when you import at that time as well, the Terraform state comes into a picture. Okay. It will look for the Terraform state and it will see that the current configuration that you are trying to import, is it currently managed by Terraform? Okay. If it is managed by Terraform, it will tell you that it is managed by Terraform. But if it is not managed by Terraform, then it will inform that this thing is not been managed by Terraform. So it will import that information into the TF state file. Okay. And in the TF state file, it will update it as managed and the resource will be imported into Terraform state. Okay.
And what is it?
How can, okay, sorry?
It is already managed by Terraform.
Okay.
Okay. And actually, someone went and manually tweaked.
So you are saying, okay.
I did the automation using
Hmm.
the Terraform state file created.
Hmm.
Okay. New developer came into my team. We did new how to do it. So he went directly in the portal. He changed some configurations there. That configuration suggested that the state file is there. And now I'm trying to import. Would it check for the deep, the difference between the configuration?
So it will it you can run so there you will not use import, you will use a refresh plan wherein it will detect the drift. You won't use import. Import is specifically a resource is created outside of Terraform. Okay. If a resource is created from within Terraform and then someone went and made some changes from the portal or wherever, your state file does not have that information. So your next run when it will happen, it will say, it will detect that this resource which was managed by using Terraform, it has some resources which are not managed within Terraform. So it will either update or destroy and recreate depending upon the nature of the resource, how it behaves at the cloud level. So for that, what you can do, if you don't want to recreate it, but you want that information to be imported to detect it, you can run refresh only plan. So that refresh only will detect the drift and it will update your plan. So you don't need to import it. Answer that question. All right. Anybody else? Any questions? So I will start. So I'm going to do three demo. Okay. One, I will create one resource group and the state file will be locally. I will create one resource on Azure. Again, it will be a public IP, but that state file will be on Azure storage account. Now, this resource, when I will call the second one, I will use data block, data output, as I said, interpolation. I will show you how, if you already have some resources created in your Azure and you want to utilize those, for example, resource group. Okay, you already have a resource group created and you want a new resource that you're going to create under that resource group. So you can give a data block. Under data block, you can specify that information and you can reference this data interpolation into your Terraform code parameter. So we'll do this three. Okay. Hopefully the demigods are with me. At home, I did this 3 times. It worked. This will be the 4th time. Let's see. Okay. Okay, here it is. So this is the one. Azure. Okay. Huh? Okay. I think what. Okay. So is this visible? Okay. So I have two folders over here, AZRG and AZVM. Now this AZVM is quite big. I see if we can run it and make it run. It will take 10 minutes. But first we start with AZRG. So if you see, I have 4 files, variables. The very first thing is variable, wherein if you see variable, I have given resource group location, name prefix, and these are some variable ARM client ID subscription. These are the credentials that I'm going to pass. Okay, this credential I'm going to pass. Now, credentials, you should not store it in any of your Terraform, what is the Terraform configuration. You should not pass it. Okay, so for that, what I'm going to do is I have this values. Okay, I'll copy them. I'll export them as TF var. I'm doing them as TF var, exporting them as TF var. This is managed service principal. Okay, so let's see if I do this. Perfect. So the variable is set. Now this variable that I've done, it has run locally. It is not stored anywhere. It is locally stored in my. But now I'm going to pass this using variables. So I have versions.tf. So here the block, if you see in this block, I have required providers, Azure RM. Okay. The source of Azure RM source is HashiCorp /Azure RM version. And I also have a provider called random. Random is because if I want, means I want to create some VM name, random resource group name, or some random name, then I need to give this as a random pet. Provider Azure RM, you see, I have given here var, but I haven't passed my any what you say uh, credentials into it. So this is a simple one. Okay, as I said, random pet, so it's going to give some random resource group name with the prefix rg hyphen something, and then it is going to create a resource. So what I will do now, here if you see, there are only four files, right? You see four in under az hyphen rg. Okay, now I do terraform for terraform fmt hyphen hyphen recursive. Now terraform code which you write, it's very sensitive to how you write the code. The indentation has to be proper, and it has to be properly formatted. Now for some reason, if your code is not properly formatted, your terraform code will fail. But don't worry, fret not. You have this command called terraform fmt hyphen hyphen recursive. It will look under the folder, within the folder, within the folder, and it will for example, if you guys want to see, I will just for fun. Okay, now this one, if you see, it's not aligned, right? Now if I give this, it aligned it, right? So whichever file is not aligned as per the indentation of terraform, it will do it. So this is one of the best command that I like. Again, okay, now I'll do terraform init. Now before I run terraform init, if I just run plan, what will happen? Inconsistency. So it is saying that terraform does not understand what I'm trying to do. Okay, because it does not know what provider it has to use, what provider information, which version does it has to use. So I have to initialize the directory. Now if you see, it has downloaded the version matching, and then it is installing. Okay, so there is, see, this one folder here dot terraform, and it has downloaded locally. Okay, but you have to make sure, if you are doing like if you're using source control or something, you have a git ignore file, and you mention that when you push it, this does not go up, because it's actually not needed by you don't need to push it to your git control, source control. And the log file is created. So log file is basically, it gives the information about which uh, provider it has downloaded, what is the version, and what is the constraint. Okay, and if there is any change, next time it will, when you do any terraform init upgrade, that time this will change. So nothing to look much into it. These are the two files. Now when I run terraform plan, okay, you see, for fraction of second, it created tf state file and tf state.log.htcl, but then it's gone. Okay, because it tried to understand that if there is any state file, does it has, but it understood, okay, I don't need to create a state file because this is the first time it is running. So it left it as it is there, and it has shown that this is what it is going to create. Now this plus is where it is going to create. Okay, I'll run terraform apply. Now tf state file is here. Okay, I have to write yes. You see mode managed. Do I see the mode managed? That means it is managed by Terraform. Okay. So this is, huh? Sorry. Uh, y- yeah, 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 yeah. No, 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 it will understand. If I go ahead and change the name of RG1, okay, if I make it RG1, then it will consider it as a new. Okay, it will consider as a new. So usually we don't do that. Okay, but if you want to do it for some reason, okay, then you can use the moved to block, moved_to moved to block, and then you can refer that old one was this, new one is this. So it will understand it does not need to take any action wherein it does not need to create or delete. It just have to rename and change it that it moves from RG to RG1. Okay. Okay. So far so good. Any questions? Oh, yes. Not every environment means. So basically, the best practice that you usually do when you create such thing is uh, for Dave. Okay, you create a folder Dave. Within that Dave folder, if you want to create multiple resources, you give those TF files. Okay, like for a Dave, for example, if you want to create a Kubernetes cluster, okay, and then you create a TF file called Kubernetes and another TF file which supports those dependencies. Okay, you fill into it and you run it. So that particular um, configuration which is run under the dev folder, that will have one state file. Okay, but let's say you have another prod as well. Okay, and you have different configuration over there, that will has its own state file. Okay, so whenever you create any resources, if it does not belong to the same hierarchy or to the same folder hierarchy where your Terraform file is, okay, it will create a new state file.
Not always I'll be executing this from my, I'll be doing the CD, that is continuous deployment. Anywhere where I'll be running this Terraform. Where the Terraform state file has to be present. And it will not always I'll be putting it from before. Because once the execution is done, the new Terraform state file will be generated. It will not be automatically
No, 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 you know, no, no. So I'm coming to that one in next one. Here, this is only how locally it's working. Okay, this is how it locally works. And if I refresh, see this one rg-bright add or something is created. So this is something that I created locally. Okay, what happens if I just delete this from here? So I'm deleting the resource group which I created from Terraform, right? Which is managed by Terra. But now I did changes outside Terraform. Deleted. Let's go and run up a plan. See, it's creating again because it understood out of this particular state, it was deleted. Now consider a scenario. Okay. Now I'm doing this locally. You are doing locally on your laptop. Okay. We are using the same code. Okay. But you are doing on your laptop. I'm doing on my laptop. Do some changes. I push it. You do some changes. You push it. The Terraform is going to actually become crazy and it will not understand what to do. So it's going to destroy, create, destroy, create, destroy, create until the point where it is going to give you a very good error where you cannot come back from it. That is the reason the Terraform state file should not be local. It should be present at a common location which is shared by all your team member. Okay. Yeah. So um, you cannot have different state file for the same resources, same resource.
No, no, no. State files for different
Yeah, you can have.
can have, right?
Yeah, yeah, yeah.
And now, this,
Provided the resources are unique.
that's true.
Huh.
That's true.
Huh.
Okay. And in practical work, this will be executed with the agent, the CD agent, continuous deployment agent,
Hmm.
right?
Hmm.
And the Terraform state file will be executed once it completes it has to update and create. How would that Terraform state file have agent?
I'm sorry, I did not actually.
Yeah, I guess something like that has
What?
to be done, right?
Yeah, you have to keep it in the storage. That's what I'm saying. Storage account, a common place storage account. You have to have it somewhere where it is accessible by all, and it's a common storage account, only accessible by Terraform, not even your team. The service principal that is running Terraform code, only that should have access, and that is what I'm going to show you next. Okay. So it's clear here. Okay. So I'm not going to run it, apply. It's just locally it's done. Now here. Okay. Now easy VM. Can you see this? Now this time when I run Terraform init plan apply, my EF state file is going to sit in this storage account. Okay, and this storage account, only the service principal that I'm running, the command, only that has access, or your global admin or another admin from your portal who has access. Normally, your user ID, my user ID can't even access it because we don't have that access. Okay, it's only the super admin or powerful or global admin will have that access, or the service account that is running your code will only have access to make a modification. Okay. So here now I'm going to create, so the Terraform state file will be, so I have this. So now you see this is different resource group ACSTF demo. Okay, this was already created by me. Okay, this VNet is already created by me, and network security group is also created by me. Okay. Now see data. If you look here, I'm providing data wherein I'm saying that rather than create, means I'm telling that I already have a resource group. I already have a security group. Okay. I already have a security group named ACSTF demo NSG. So whenever I want to create a NIC, or I want to create VM which needs a NIC, or any public IP which needs connection to the NIC, rather than creating a new NSG every time, I can pass this data information. Okay. So Terraform will understand that rather than creating, I have to utilize the current existing resource. This is not importing. Okay. It is not managed by yet. It will not manage. Okay. It will just understand that I don't have to create it. It is already is existing and I have to utilize it. That's what this data will do. Okay. So I have network security group, and so there is this. I've created a resource group. Okay, already. So I'm providing in the data. I have a VNet, I have a network security, and I have a subnet. Okay. Now you see I have interpolation, which I was talking. Now virtual network name. My virtual network name is ACSTF demo VNet, right? But here I have given data Azure RM virtual network. That is data Azure RM virtual network. This is a placeholder for Terraform dot name. Now, if my resource group has a parameter called ID, I can just remove this. Okay, I have the editor. and I can put ID. Okay. So it will, rather than getting name, it will get ID. Now, if I want location, so I type location. So it will get me only location of the resource group. Okay. But here I want it to give a name. I don't want ID. So I'm keeping it as name. Okay. Got it? Clear till now? Any questions? I think we have 5 minutes. I'll quickly run through this. Okay. And yeah, again, if the variables you will see, these are the same variable, the subscription ID, tenant ID, secret ID, access key that I've given. Okay. Versions, you see the only change is backend I've given this. And yeah, still my credential, I have not passed it anywhere. Okay. It is taking from my local environment variable where I've set it as tfvar, vm.tf. Now this is very big one. Okay. So if you see, I so later I will share with you guys this repo, so you guys can download and run it in your lab as well if you want. But I'm just going to run the above part because this will take some 10 minutes to deploy and we don't have that much time. So if you see what it is going to do is I have given a data Azure RM location. So you see I have interpolated those information from data rather than giving just the name. Okay. I have given the information that you go look for the data source, fetch the information and give it to me. Okay. Now I will remove this. Okay. All are there. Then I have to show you import as well, right? So let's go with this. Terraform fmt -hyphen recursive. So when it gives blank, that means no format has to be done. Do Terraform in it. It created Terraform providers. Okay, it created a state file, but that state file has information about the what container need to use for the state file. Like the container is this, and what is the file name that it will create terraform.tf state and ACH demo state file. So nothing related to resource, but it has created a file which has information that where it needs to create the state file. Okay. Terraform plan. So Terraform plan, it is saying that it's going to create one public IP resource. So yes. Oh, sorry. Something wrong with my laptop. Sorry. Terraform apply. Yes. It's creating a preface of public IP. If now I go here, I refresh, take some time. See, the public IP is created. Now, if I go to my container, this TF state file is created, which was not there earlier. If I open this TF state, see, the mode is data, right? Azure RM subnet mode is data. It does not say import or manage. It says data. That means it has connected via API to that data source. It collected that information, stored that information. That whenever this information I get, I have to utilize one of the parameters, like name. Name is this, and if you go to resource group, there will be location. So it will use those information. This is data. But if I go down, the public IP was created by Terraform, right? Now this is managed. So if I do any changes to this particular resource, it will be outside of Terraform. So next time when I run, if I delete this public IP and next time run, it will create a new for me. Or if I just change the name of this public IP, or I do something, I change from standard to basic or premium, it will understand and it will then try to make that change rather than destroy and recreate. If the value supports it, it will do it. So far, so good. Okay. So this is the second one wherein we had seen one local state file and remote state file. Okay. Now, what we are going to do now, if I go to home, import S3. Yes, I have one S3. Sorry, it should not be S3. It should be storage account. Sorry, SA. Okay. Yeah. So now this particular state file, this particular, as I said, this storage account was not created using Terraform. Okay. This was created by me manually. But now I want to have this information in my Terraform. So now I'll import this information. And how to do that? Now, if you see it's AZVM, it is still the same folder. Okay. My resource IP address resource was created in this folder, right? In this, the resource block. Now I'm going to import SA, that is storage account. So now you will see how after importing the state file will look like. Now state file is backend. Okay, it is utilizing same thing, but now I'm importing within that infrastructure. Okay. So for that, first, what I will do, I will export the ID. Okay. Now, what ID is this? This is storage account ID. If you guys see very well, it's like subscription, my subscription ID, resource group, demo, and the name ACS demo state file, right? So this is because I am going to run this command. Okay. Now, before I run this command, $SA ID. So what I'm saying, the environment variable that I created earlier, right? So that environment variable I'm passing toward my import. Okay. Now see the command import is Terraform import Azure RM storage account dot ACS demo TF state. Okay. If I go here, resource, Azure RM storage account, then placeholder. Okay. And before means you just can't give this, you run this, no, only this without providing this information. Okay. If you don't give this block information and if you just still, okay, let's do that. Okay. Now for Terraform, it does not exist. Okay. If I just run this, what is saying? Before importing this resource, please create its configuration in the root module. That means you simply cannot just run az import and that and give the ID and it will magically appear. No, you have to create the configuration like I created here, resource Azure RM. But the information that you are going to put into it, it should match the information that is present in your Azure. Okay. Sorry. Okay. So now, do you think it will work? Hopefully it works. This is the last one. Import successful. Now, let's see what does read file shows. Now that storage account should be somewhere here as managed. Earlier this was not there, but now it did not create. It already existed. But now um, Terraform has information about it. So now if I go and make any changes and next time I run Terraform plan or apply, Terraform will understand that it has been changed outside Terraform, and then it will ask you to either recreate or in place upgrade or whatever that information it will ask you to do. And with that, I'm done with my session and demo. Any questions? That is just for me. You don't need to worry about it. So basically, it's not good to have that. Okay. And don't show it and openly. But since I'm doing a demo, I'm going to delete all those credential files. So those cred file are just for me that my demo should go very good. Okay. So I don't have to search for things later. So nothing. It's just I created the Azure Service Principal IDs, right? The managed ID. So those information are huge. They're long GUID IDs. We can't remember it. So I just kept it somewhere. So I can just run it and make it, you know, available to us. No. There is no difference. It's just for me. And if you guys would like to connect with me, this is my LinkedIn. You guys can connect with me. And with that said, thank you. This is the feedback. Please give us the feedback. You guys can take the swags for